Okay, this video is lesson 3.1 on exponential functions. And we're just basically looking at what exactly an exponential function is. All exponential functions are in the form some number raised to the x. Like it might be 2 to the x, 3 to the x, 4 to the x. I didn't mean to open that right that second. Go away. And this is your parent graph. We're adding in a new parent graph. We did it before. If I was standing up in front of you, my arms would be doing this. Okay, that was the one that we did for our exponential function. And it says it has a positive association. That means it's all on top of the x-axis. It's above all positive numbers. It has no real zeros. It has an asymptote of the x-axis. I'm just going to go ahead and draw it over here to the side. It has an asymptote, horizontal asymptote at y equals 0. All of them pass through 0, 1. That's the parent graph. Their domain is all real numbers. Their range is y is greater than 0. And if, let's say it was 2 to the x, it passes through the point 1, 2. And then it just kind of does this. Okay. If it was 2 to the negative x, that's a reflection of the first across the y-axis. It has a, whoops, I'm lying. Positive association means it's rising. It's exponential growth. Sorry about that. And negative associations means it's decay. It's falling from left to right. It's decreasing. So has an asymptote on my x-axis, passes through the point 0, 1. Let's do 2 to the negative x. And what I could do is make like a little xy chart, negative 1, 0, 1. And if I do negative 1, 2 to the negative, negative 1 would be 2 to the first, which would be 2. So if you don't know what to do, you can always make a little xy chart. 2 to the 0, anything to the 0 is 1. And then 2 to the negative 1 would be 1 half. So it would be here. Okay. Domain all real numbers, range y is greater than 0. And then this is the little prerequisite knowledge that you should have learned in Algebra 2, but I'm to the point now where I don't even ask you what you learned in Algebra 2 anymore, because y'all always say that you know nothing. So, what I'm going to do is I'm going to break down both sides as simple as I can get them. 2 won't break down, but 32 will. 32 is 16 and 2, and then 16 is 8 and 2, and then 8 is 4 and 2, and then 4 is 2 and 2. So that's 1, 2, 3, 4, 5 2's. So that's 2 to the 5th. The 2's cancel, so x equals 5. So that's not too bad. Try number 2. Okay, so break it down. 27 is 9 and 3, and then 3 is 3 and 3. So that's 3 to the 3rd, and then 3 to the x. Well, the 3's cancel, and x equals 3. Number 3 is the same way. Do it again. Break down 8. That's 2 and 4, 2 and 2. So that's 3 2's. So that's 2 to the 3rd. The 2's cancel. X equals 3. And then 81 is 9 and 9, 3 and 3, 3 and 3. So 81 is 3 to the 4th. So I've got 3 to the x plus 5 equals 3 to the 4th. The 3's cancel. That leaves me with x plus 5 equals 4. And then you just solve whatever equation is left. X equals negative 1. That is not a 7. It looks like a 7, but it's actually a negative 1. And then number 5, there's actually 2 ways to do it. You've got 64, which is actually 8 times 8. So if this number and those numbers are the same, I could just stop and say 8 squared equals 8 to the x plus 2. Kill the 8's. 2 equals x plus 2 minus 2 minus 2. X equals 0. Or, yeah, I just erased it. I'm going to do it again another way. I just don't have enough room. So I could, if I had not realized that 64 was 8 times 8, I could have went all the way down and 2 and 4, 2 and 2, 2 and 4, 2 and 2. So that's 1, 2, 3, 4, 5, 6 twos. So that's 2 to the 6th. And then 8 is 2 to the 3rd to the x plus 2. And I just distribute my 3. So it would have been 2 to the 6th equals 2 to the 3x plus 6. So 6 equals 3x plus 6, and then finish it. 0 equals 3x, 0 equals x. Now 6, I'm going to do the same way I just did the second one, because 32 won't break down to 8 times anything, so I'm going to have to break them both down anyway. 32 is 4 times 8, and then that's 2 and 2, 2 and 4, 2 and 2. So that's 1, 2, 3, 4, 5 2's. And then 8 is 2 and 4, 2 and 2. So that's 3 2's and 3x minus 1. So the 2's die. So 5 equals 3 times 3 is 9x. 3 times 1 is 3. And then I add 3. 8 equals 9x. X equals 8 over 9. And then the last one, number 7, which you may not have even realized was there. I've got a 9 in the bottom. First thing I'm going to do is move the 9 to the top. Anytime you move a number, it becomes a negative exponent, or if it's already negative, it becomes a positive exponent. Then I'm going to break it down. 9 is 3 times 3, so that's 3 squared to the negative 1. And remember, when you raise a power to a power, you multiply, so that's 3 to the negative 2 equals 3 to the 2x minus 1. Cancel the 3's. Add 1. Negative 1 equals 2x. Divide by 2. X equals negative 1 half. And I'm not going to do this entire lesson. I'm actually going to stop after example 2. The rest of this goes with the next sheet later on in your packet. And I'm just going back to the graphs one more time. It's the same thing again. It says graph, whoa, that's interesting. I'm trying to make it bigger. Whoa. It says on the same set of axes. I'm just going to graph them 3 different times because it gets kind of crowded on the same set of axes. I know you only have one, but it'll be alright. 4 to the x. If I'm not sure how to graph it, okay, I can make myself a little xy chart. Negative 1, 0, 1. 4 to the negative 1 is 1/4. 4 to the 0 is 1. 4 to the first is 4. So it'd be negative 1, hold on, negative 1, 1/4. So about here, 0, 1, 1, 4. And remember, it has they all have an asymptote unless it shifts up or down. And then you just connect the dots. Domain, all real numbers, range, y greater than 0. And then I've got 4 to the x plus 2. Well, how is that going to be different? If this is 4 to the x, how did it change from 4 to the x to the 4 to the x plus 2? Well, a plus 2 on the outside shifts the graph up 2. So I go up 2, and everything's going to move up 2. My asymptote is going to move up 2. And every point that I had a point at 0, 1. Now it's going to be at 0, whoops, not right there, 3. I had a point at negative 1/4. Now I'm going to have one at negative 1, 2 1/4. I had one at 1/4. Now I'm going to have one at 1/6. And you connect your dots. Domain, all real numbers. Range, y is now greater than 2, because it's always going to be related to your asymptote. And then I've got 4 to the x minus 3. What is that going to do to my original graph? It's going to move it right 3. And this is the compare and contrast the graphs part, up to right 3. So if I move my original graph to the right 3, my asymptote is going to be in the same place. My original point that was at 0, 1 is going to move over 1. My point that was at 1, 4 is going to move over, actually not over 1, I'm sorry, over 3. Just kidding. It was at 0, 1. Tell you what I'm going to do. Nope, I'm just kidding. It was at 0, 1. 1, 2, 3. It was at 1, 4. So 1, 2, 3. And there was 1 at a half, or gosh, negative 1 a fourth. Sorry. 1, 2, 3. So it's going to look like that. The domain, all real numbers, the range, y greater than 0. And we're going to stop after example 2. It says use a calculator to evaluate each expression to the nearest 10,000th. 10,000th is 4 places. So 5 to the square root of 2. 9.7385. And 0.4 to the pi. 0.0562. 0.0562. Okay. The end. Bye-bye, mathematical pi. Or